Okay, Unit 5 is Introduction to Calculus. This unit is designed to introduce the main concepts taught in first year calculus. You will examine what happens when a graph has a break and determine what the y value approaches based on the direction of x values. The unit ends in finding constant instant slope change on a curved function by finding the derivative. So today we're doing 5.1. We are going to graph rational functions and their asymptotes. Hopefully you remember from last year, an asymptote is a line that a graph approaches but never crosses. I have two terribly cheesy jokes for you. The first one is from Lord of the Rings. You shall not pass. So the graph is approaching the asymptote but not passing the asymptote in both directions here. And then I have my favorite, which is holy shift. Look at the asymptote on that mother function. So notice the graph is shifted and it has asymptotes. So back to seriousness. A rational function is a polynomial divided by a polynomial. So in this example, we would be dividing m of x by n of x. And that gives us f of x. To find the horizontal asymptotes of a graph, you have to look at the exponents p and q. If p is less than q, then you have a horizontal asymptote of y equals 0. If p equals q, then to find the equation of your horizontal asymptote, it's y equals the coefficient of our top divided by our coefficient of our bottom. So this would be whatever the a value is divided by the b value. And then finally, if the exponent on top is greater, if p is greater than q, then it won't have a horizontal asymptote. Instead, it will have a slant asymptote, which we'll talk about later. Vertical asymptotes, these are values that are not in the domain. So we learned back in Unit 1, you can't divide by 0. So to find the vertical asymptote, you take this bottom function and set it equal to 0. So in this case, it would be n of x, set it equal to 0, see what you cannot divide by. That creates a vertical asymptote. X-intercepts is when you set the top of the fraction equal to 0. So it'd be m of x is equal to 0. This works because your x-intercept is when y equals 0. So if this is 0, you would multiply n of x over, which makes the top equal to 0. Your y-intercept is when x equals 0. So you're just going to plug in 0 for all of your x values and see what you get. So f of 0. Holes in the graph are when factors cancel on the top and the bottom. Means it will have an open circle somewhere. So this means you might have to t-chart or factor and see if something cancels. Slant asymptote is, like I said, p has to be greater than q, meaning it won't have a horizontal asymptote, but it has to be greater than q by one value. To find the equation of your asymptote that is slanted, you have to use synthetic or long division to find the equation of the line. The good news is you can ignore the remainder. It's just the part that's before the remainder. Okay, so for number 1, we're supposed to graph f of x equals 2 over x plus 5. So for your horizontal asymptote, you look at the exponents. So notice there are 0 exponents on top and 1 exponent on the bottom. So that means the exponent on top is less than the exponent on the bottom. Whenever p is less than q, the horizontal asymptote is the equation y equals 0. For your vertical asymptote, you set the denominator equal to 0. So x plus 5 equals 0. That's going to give you x equals negative 5. That is the equation of your vertical asymptote. The x-intercept is when you set the top of the fraction equal to 0, so that gives me 2 equals 0. Notice that makes no sense, so this does not have any x-intercepts. Then your y-intercept is when you plug in 0 for x. So this is 2 over 0 plus 5, which is just 2 over 5. Remember, the y-intercept is a point, so it's 0 comma 2 over 5. So yes, you have to show this work. I need to see where these values are coming from. So always show this part over here as well. Once we have our table filled in, we can go ahead and plot this on our graph. So we have y equals 0 as our horizontal asymptote. We have x equals negative 5 as our vertical asymptote. So here's where x equals negative 5. Draw the vertical line. We don't have any x-intercepts. My y-intercept is a positive 2/5. Well, that's less than 1, so it's somewhere between 0 and positive 1. So let's just put a dot there. So, thinking of the vertical line test, I can see that the graph is forming along the asymptote here. It's going to get close to this asymptote, it's going to get close to this asymptote, and it's going to go through this point. I have no idea where the graph is to the left of my vertical asymptote. So I'm going to pick any number over here that's to the left of my vertical asymptote. So let's say I'm going to pick negative 6. If you plug in negative 6, you get 2 over negative 6 plus 5. Well, negative 6 plus 5 is negative 1. So it's 2 divided by negative 1, which is negative 2. So we're going to plot this point at negative 6, negative 2. So notice now you can see that the graph is going to curve and match up with these asymptotes. So let's go ahead and draw on our graph. It's going to be a sketch, but it'll have to go through these points and not touch and not pass the asymptotes. So it'll look something like this, where notice it's getting close to the asymptote here, close to the asymptote here, but not passing. And then the same thing's going to happen here. Notice how this passes the vertical line test. You can always double check by typing this into your calculator to see what you get. Okay, number 2, to find your horizontal asymptote for f of x equals x plus 2 over x minus 5, you look at the exponents. So notice the exponent here is 1, the exponent here is 1, so the exponents are equal, so p equals q. When you have that, to find the equation of the line, you take the coefficient up here and divide it by the coefficient down here. So it's 1 divided by 1, which is 1. So your horizontal asymptote is y equals 1. Your vertical asymptote is when you set the denominator equal to 0. So when I add the 5 over, the equation of the line is x equals 5. Your x-intercept is when you set the top of the fraction equal to 0. So I'm going to get x equals -2. But your x-intercept isn't an asymptote, it's a point. So the x-intercept is -2, 0. To find the y-intercept, you plug in 0 for the x's, so we get 0 plus 2 over 0 minus 5. So the point for your y-intercept is 0, -2/5. Make sure you're showing this work over here. So we can start graphing this. We have a horizontal asymptote of y equals 1. So here's y equals 1. Draw a horizontal asymptote. A vertical asymptote at x equals 5. So here's x equals 5. Draw the vertical. We have an x-intercept at -2, 0. And a y-intercept of 0, -2/5. So it's between 0 and -1. So notice I can see that it's curving here. It can't be up here since that would make it fail the vertical line test. It's going to be down below the horizontal asymptote. Now over here, I don't know if it's above the horizontal asymptote or below. So you have to pick a point over here and see where the graph is. So anything to the right of this asymptote, say x equals 6. So when you plug in 6 for x, I'm getting 6 plus 2, which is 8, over 6 minus 5, which is 1. So we have 8 over 1, which is 8. So we can plot that point at 6, 8, put a dot. Now we can kind of see where it's curving. So you have this curve here, getting close to the asymptotes without crossing, going through 6, 8. And then the same thing is going to happen here. It's going to go through those 2 points and get close to the asymptote without touching. Number 3, to find the horizontal asymptote, you look at the exponents. But notice, for example, here, you can actually factor this denominator. So we're going to actually do that. So if you t-chart this, you're going to get x and x, a +2 and a -2. So this is going to become x plus 2 on top. Then this is an x plus 2, x minus 2 on the bottom. You should notice that the x plus 2's cancel, leaving me with 1 over x minus 2. So now I'm going to ignore this and only look at the reduced fraction over here. However, I have to take into account what I factored out. Remember, when a factor cancels, it creates a hole at that value. So if you were to set this factor equal to 0, you're going to get -2. So there's going to be a hole in the graph at x equals -2. And we'll talk a little bit more about that in a moment. Now we can look at the exponents. Notice there's no exponents here and 1 exponent here, so p is less than q. So this has a horizontal asymptote when this happens of y equals 0. Vertical asymptote, you set the denominator equal to 0. So in this case, I get +2. Notice I'm using the reduced one, not the original. To find the x-intercept, you set the top of the fraction equal to 0. Notice that does not make any sense, so there are no x-intercepts. And then for your y-intercept, you plug in 0 for x. So it's 1 over 0 minus 2, which is -1/2. So it's a point, 0, -1/2. You want to make sure you have all this information. So to graph this, we have a horizontal asymptote of y equals 0, a vertical asymptote of x equals 2. We don't have a x-intercept. We have a y-intercept of 0, -1/2. Should be up a little bit. Then you have a hole at x equals -2. So I'm going to draw in a vertical line here. So what that means is as the graph gets close to that line, this is going to make an open circle. So this is just a placeholder to remind me to make an open circle on the graph here. So notice we know where the graph is going to the left of this vertical asymptote. We have to figure out what's happening on the right of our vertical asymptote. Is the graph up here or is the graph down here? So picking any number that is past our vertical asymptote, let's say we pick the number 3. When you plug in 3 to our reduced fraction, it's 1 over 3 minus 2. 3 minus 2 is 1, so 1 over 1 is 1. So we can plot that point at 3, 1. Now I can see that it's going to curve through here and go through that point, and it's going to curve through here going through this point. However, we have a reminder here that where the graph crosses this line, it will create an open circle. That, remember, is our hole in the graph. If you were to graph this on your calculator, you won't notice the hole in the graph. But if you were to go to the table, you will have an error in both x equals +2 and x equals -2. So it won't show the hole, but it will show an error in your table. Okay, number 4. Notice that we have x squared plus 1. If that was -1, I could t-chart, but it's not, so I can't. So we're just going to go ahead and start. Our horizontal asymptote is based on our exponents. So the exponent on top, 2, is greater than the exponent on the bottom, 1. So our exponent p is greater than q. When this happens, you do not have a horizontal asymptote. Instead, you're going to have a slant asymptote, which we'll find in a moment. To find the vertical asymptote, you set the denominator equal to 0. So we add the 1 over, we get x equals 1. To find the x-intercepts, you set the top equal to 0. So notice when I minus the 1 and then take the square root of both sides, you can't square root -1, so this does not have any x-intercepts. For your y-intercept, you plug in 0 for x. So it's 0 squared plus 1 over 0 minus 1. That gives you 1 over -1. So our y-intercept is 0, -1. So now we have to find our slant asymptote, which means I'm going to use synthetic division. We are dividing x squared plus 1 by x minus 1. So to do this, we are going to use the coefficients on the top. So we have 1. Notice we're missing a term, so that's 0. And then our coefficient 1. And we're going to synthetically divide that by +1. So remember synthetic division, you drop the first number, then we multiply, and then we add. So 0 plus 1 is 1. 1 times 1 is 1. 1 plus 1 is 2. So we've synthetically divided this by this. Now I can reduce the power. So if this was x squared, this is going to be x plus 1 plus 2 over what we divided by, x minus 1. Now remember what I said. For the equation of the line, we are going to ignore the remainder. So this is the equation of my slant asymptote, but we need a y equals. So the equation is y equals x plus 1. So when we graph this, we don't have a horizontal asymptote, but we do have a slant asymptote where our y-intercept is 1 and our slope is up 1 over 1, up 1 over 1, up 1 over 1. We do have a vertical asymptote at x equals 1. We don't have any x-intercepts. And we have a y-intercept at 0, -1. So if the graph has to go through this point, I can see it's going to curve this way without crossing those two lines. But I don't know if the graph is going to be over here or if it's going to be up here. So to figure that out, you have to pick a number to the right of your vertical asymptote. So say 2. When you plug the 2 in, you get 2 squared, which is 4, plus 1, which is 5. So you have 5 divided by 2 minus 1 is 1, which gives you 5. So when we plot 2, 5, that is our second point. So you should be able to see that the graphs are going to curve through here and curve through here. Okay, next problem. To find the horizontal asymptote, you have to look at the exponents, but notice how I can factor the denominator. This is a difference of squares. So if I was to t-chart, we'd get x and x, positive 3 and negative 3. So this is going to become 3 over x plus 3, x minus 3. Notice how nothing cancels. So this isn't going to help us very much. So when we compare our horizontal asymptote, notice the exponent on top, p, is less than our exponent on the bottom, 2. So if p is less than q, then we have a horizontal asymptote of y equals 0. For the vertical asymptote, you set the denominator equal to 0. It doesn't matter which one you use. If you set this to 0, we would add the 9 and then square root both sides. So we're going to get plus or minus 3. Over here, notice you'd get negative 3 and positive 3 as well. So the vertical asymptote is the equation x equals 3 and negative 3. And yes, you could put plus or minus 3, same thing. Your x-intercept is when you set the numerator equal to 0, so 3 equals 0. That's not true, so this does not have an x-intercept. And then finally, your y-intercept is when you plug in 0 for x. So we have 3 over 0 squared minus 9. The 0 squared goes away. I'm left with 3 over negative 9, which reduces to negative 1/3. So our y-intercept is the point 0, negative 1/3. Make sure you're showing all this work. So to graph this, we have a horizontal line through y equals 0. We have 2 vertical lines, one at 3 and one at negative 3. There are no x-intercepts. And we have a y-intercept at 0, negative 1/3, so below 0. So when we look at this graph, I can see the graph has to go through this point. So it's going to curve and go down and curve and go down. So I have an idea of what's happening between my 2 vertical asymptotes. However, I don't know what's happening to the right of this asymptote or to the left of this asymptote. So this time I have to plug in 2 x values. So let's say I plug in x equals 4. When you do that, you're going to get 4 squared, so we have 16 minus 9. So this is going to become 3 over 7. We can go ahead and plot that point. It's less than 1. But I also have to pick a point that's to the left of this asymptote, so let's say negative 4. When you plug in negative 4 and square it, it still becomes a positive 16, so we're still left with 3 over 7. So when we plot that point, it's somewhere about here. So graphing these, I can see it's going to curve to the asymptotes there. That's weird. These are going to curve down, and then this is going to curve up to the asymptotes here.